Hello, my name is Michael Behm, and I'm a practicing geophysicist with a career spanning 25 years in both academia and the private sector. I have worked in different fields such as natural resource exploration, civil engineering, earthquakes and other natural hazards, hydrology and glaciology. I also have a long and successful track record in teaching and advising students at university in Europe and the United States. I have published 42 peer-reviewed articles and contributed to more than 130 conference abstracts. I'm excited to be an instructor in the course Geophysics for Mining, Engineering and Construction with InGeo Experts. In this short video, I will explain why this course can be relevant and beneficial for you and what you can expect from it. Geophysical methods are widely used to explore and monitor the subsurface. They find applications in mining for resources such as critical minerals, in constructions and infrastructure health monitoring, and in protection of the environment. Geophysics can help to bring down project costs by reducing the number of exploration drills, by mitigating risks, and generally by providing crucial information for further project planning. Decarbonization and transformation of our energy system bring a completely new focus to analysis and characterization of the subsurface. Storage and transport of conventional and new forms of energy require accurate knowledge of the subsurface from shallow to deep. The construction of hydropower plants, wind turbines and solar power plants is based on quantitative models of the shallow soil and ground structure. The quest for natural hydrogen and geothermal reservoirs depends on accurate geologic and geophysical images of the subsurface. Society-wide efforts and policies towards a sustainable future, such as the European Union's Green Deal, require massive investments in mining for critical raw materials, and geophysics will play a major role in these fields as well. And add to this the still lingering dependence on hydrocarbons and nuclear fuels, areas where geophysics always play a major role. The history of the modern world is a history of urbanization. The concept of smart cities involves increased usage of a city's subsurface space for traffic, communication, storage and decentralized energy systems. Conventional and new forms of tunneling and subsurface monitoring integrate geophysical data and innovative sensor systems such as fiber optics into engineering and construction workflows. Optimization and monitoring of critical infrastructure and building materials such as concrete can benefit from geophysical analysis tools as well. More specifically, typical applications and tasks include the estimation of geomechanical parameters such as soil stiffness and shear strength, investigation of bedrock depths, lithology discrimination, mapping of fault zones, or cavity and utility detection and localization. In the realm of hydrology, geophysics can help to map groundwater tables and to identify preferred subsurface fluid pathways. Looking at deeper layers, the geologic imaging of hydrocarbon and geothermal reservoirs is one of the most important application scenarios. All those examples illustrate that knowing and understanding geophysical concepts and the benefits, as well as the limitations, is crucial for engineers, geoscience professionals and project managers alike. In this course, we will discuss the basic foundations of the most important geophysical methods such as seismic, ground-penetrating radar, electrical methods and gravity and magnetics. We will learn how data from geophysical measurements are processed into geophysical subsurface models and images, and what relevant information for engineers and geoscientists can be extracted from those results. Case studies are used throughout to highlight practical aspects and to illustrate benefits and limitations of geophysics. Exercises and optional additional readings are offered to deepen understanding and widen the spectrum. After the course, you should be able to judge if and what geophysical methods can be useful for your project, and to get an idea about the timeline and efforts and costs involved. I would be very happy to see you in the course. If you have any questions or would like to discuss if and how this course could be beneficial for you, please do not hesitate to contact me via email.